Problem number 36. Draw a second resonance structure for nitromethane, a compound used in drag racing fuels and in the manufacture of pharmaceuticals, pesticides, and fibers. Here is one Lewis structure for nitromethane, and you're asked to draw a second resonance structure. So what resonance structures are they have the same atomic arrangement but different electron arrangements. So basically, using the atoms, keeping the atoms in the same places, and they're connected to each other. The connections are the same, but could we have drawn the bonds any differently? Okay, so in other words, I copied the structure down over here. So using this same atomic arrangement, can we draw the electrons on there any differently than over here? And looking at this nitrogen, notice that it has a double bond going to this oxygen and a single bond going to that oxygen. Why does the double bond have to go to this one? Why couldn't it go to that one and then the single bond go to this one? And that's the idea here. When you have what looks like maybe one option, consider the other option. Keeping the atoms in the same place. The other option is, let's put the double bonds going to this oxygen and the single bond going to that one. And so the way we turn this into another possible resonance structures, we can use arrow formalism. Let's take these, one of these bonds, let's put it back onto this oxygen, and let's bring this pair down to form a double bond. This is called arrow formalism. So let's bring these electrons back there, and let's bring those electrons down here, and let's redraw the structure. So let me put back all the other bonds. Okay, going to the nitrogen. Now this time there's a single bond going to that oxygen, and now there are 3 lone pairs on this oxygen. And then there's a double bond going to the other oxygen, and there are 2 lone pairs going to that one. And that's a different resonance structure. And you can kind of use this double arrow. This is usually used to indicate resonance structure. So you see how the atoms are in the same positions. They're connected to each other. So the carbon is still connected to these 4 atoms. This nitrogen is still connected to these 3 atoms, but the bonds are drawn a little bit differently. So that's how resonance structures are.